Hello and welcome to Mrunal's Math Tutorials, and in today's video we are going to learn about binomial expansions. We are going to look at how do we find coefficient of a particular term in a binomial expansion. I'm going to discuss some past paper questions for Cambridge AS level mathematics, and it is the same for Edexcel as well and for IB Maths. So look at the first question. Find the coefficient of x in the expansion 2 over x minus 3x to the power of 5. Let us remember what is a general term in a binomial expansion. A general term in binomial expansion is given as NCR a to the power of n minus r, b to the power of r. So what are these n and r? R is something that we need to work out. N is 5 in this example. A is going to be 2 over x, b is going to be minus 3x. So we can rewrite this as 5r, 5cr, a to the power of 5 minus r, b to the power of r. So now we need to work out what would be the value of r so that we can calculate the coefficient of x. So what I'm going to do over here is I'm going to write an equation using the x's over here. So I'm going to ignore the coefficients 3 and 2 here, and I'm just going to make use of x. Now here the x is in the denominator, so we can take it in the numerator. So the power of x would be negative 1. The whole thing is to the power of 5 minus r times x to the power of r, and we are looking for the coefficient of x. So I can write this as x to the power of 1. So apply the rules of indices. So this is going to be x to the power of minus 5 plus r. So remember, we are multiplying by minus 1. So minus 5, minus into minus is plus, minus 5 plus r from here. When we multiply two indices, we add the exponents. So that gives me x to the power of minus 5 plus 2r is equal to x to the power of 1. Since the bases are same, we can equate the exponents. We are going to get minus 5 plus 2r equal to 1, or 2r is 6. That gives me r is equal to 3. Once you have calculated the value of r, go back at this step and you're going to substitute r as 3. So that gives me 5c3 2 over x to the power of 2 minus 3x to the power of 3. Remember, 3 plus 2 adds up to 5. Now use your calculators to calculate what is 5c3. So that's 10. 10 times 4 over x square times minus 27 x cube If you simplify, multiply the like terms, you're going to get 10 times 4 is 40. 40 times minus 27 is negative 1080 x. So the coefficient of x is negative 1080 in this question. Now let's go ahead and do a similar question. I would like you to pause and try on the steps. So we are having in this question to find a term which is independent of x. That means there is no term, it's a constant, there is no term which has an x, it's a constant term. Again, we rewrite the formula for general term. N, in this case, we can see it's 9, a is 2x and b is minus 1 over 4x square. N minus r minus 1 over 4 x square to the power of r. Again, let us set up equation with r. I'm just going to do it on the side so that you can see quickly. So we're having x to the power of n minus r. I may rewrite this as 9 minus r. 9 minus r. So 9 minus r times x square, which is in the denominator. If I take it in the numerator, it's going to be x to the power of minus 2 r is equal to a term independent of x, means the power should be 0. Yeah. So add the exponents. So 9 minus r minus 2r is equal to x to the power of 0, or 9 minus 3r is equal to 0. R is equal to 3. Remember, it's not necessary for you to write down these. You can just write an equation with the exponents. But it's just easier if you include the x's as well. So once you have got r equal to 3, come back and replace the value of r as 3 here. So 9c3 2x to the power of 6 minus 1/4 x squared to the power of 3. Use your calculators to work out 9c3. That's 84 times 2 to the power of 6, which is 64x to the power of 6 times minus 1 over 64x to the power of 6. Note that this cancels, this also cancels, and your answer is negative 84. This is the term which is independent of x. Let us try another example. Now here we need to work out the coefficient of 1 over x cube. So again, n in this case is 7. So 7cr, a to the power of 7 minus r, b to the power of r. On the side, you can work out the value of r. So we are having x to the power of 7 minus r times this x is in the denominator with power 1. So if you take it in the numerator, it's going to be minus 1 to the power of r is equal to x to the power of minus 3, because the 3 is in the denominator here. Apply the rules of indices. 7 minus r is equal to x to the power of minus 3. Equate the coefficients. So 7 minus 2r is equal to minus 3, or 10 is equal to 2r, or r is 5. Once you calculated the value of r, come back here and substitute r as 5. So you're going to get 7c5 x to the power of 2 minus 2 over x to the power of 5. That gives me 7c5 is equal to 21x square minus 32 over x to the 5th. So 21 times minus 32 gives me negative 672 1 over x cube. So the coefficient of 1 over x cube is negative 672. Let us try one more example. Now here we're having n is 7, a is 3x and b is 2 over 3x square. Pause the video and give it a go. See if you can solve it by yourself. Alright then, if you have tried, check your answer. 7 CR, a to the power of 7 minus r, b to the power of r, and we need to work out the value of r. So I'm just going to work out on the side, set up an equation. So we're having x to the power of 7 minus r. This x square is in the denominator. Take it in the numerator. So it's going to be x to the power of minus 2 r is equal to, we are looking for the coefficient of 1 over x square. So this is going to be x to the power of minus 2. Apply the rules of indices. 7 minus r minus 2r equal to x to the power of minus 2. Equate the coefficients. That gives me 7 minus 3r equal to minus 2. And 9 is equal to 3r, or r is equal to 3. Come back here and substitute the value of r as 3. So you get 7c3, 3x to the power of 4, 2 over 3x square to the power of 3. Use your calculators to work out what is 7c3. That's 35 times 81 x to the 4th times 8 over 27 x to the 6th. Calculate 35 times 81 times 8, everything divided by 27. That gives me 840 1 over x square. So the coefficient of 1 over x square is 840. Alright then, if you liked this tutorial, please like, share and subscribe to my channel for more videos. In the next video, I'll be looking at more complex examples on binomial expansion. Thank you and see you later.